Welcome students, this is your video tutorial on how to successfully complete the Hooveris Dry Lab posted online to help you model evolution by natural selection. So before you start this lab, you're going to need to collect a few things. You're going to need a few sheets of paper, some tape, at least 2 straws, a tape measure, 6-sided die, so it's just a regular die you use in any board games, a coin, doesn't matter what kind, just one that you can flip, and a pencil to record your observations. And of course, your dry lab outline that you can download from the Teach Yourself Biology 11 website. The first thing you're going to have to do to complete this activity is to successfully construct 2 Hooveris birds. So as you can see in the diagram provided, you will need 1 straw and 2 loops of paper that are 10 centimeters by 2 centimeters. You then tape these 2 wings 3 centimeters from each end. Pretty easy, just do this twice. The next thing you're going to do is you're going to fly both of these birds identically. So you're going to be sitting in the same chair, same starting point. You need to be sitting in the same way, throw it the same way, use it with the same strength. Try to keep as many things identical as you can to ensure that the flight difference is because of a difference in the bird, not a difference in the way you threw it. After you've thrown both of these birds, ensuring that the wing loops are up, you will record the distance that the bird flew in centimeters and record that in your chart, as well as any qualitative flight observations. So unlike quantitative flight observations, which would be your distance, which are quantities, these are qualitative flight observations. So did one bird hook to the left? Did it hook to the right? Did its wing rip? What quality things happened that describes the way the bird flew? Then after that, you're going to determine which bird is a more successful flyer. No, only one of your 2 birds will reproduce. So you'll have to determine which bird was a more successful flyer from things like the qualitative observations you recorded and the quantitative distance it flew. So only one of those 2 birds will reproduce. This is because it could fly more successfully. So maybe it could fly farther to get better food, maybe it could fly farther and get a good mate, maybe it was just more physically fit and mates wanted to reproduce with it more, but only one of those 2 birds will reproduce. So the result of that reproduction will result in one baby that's identical to its parent. So you will take the one bird that more successfully flies and just pretend it reproduced by cloning and sit it over on the side, don't touch it. The other baby, or the less successful flyer, will reproduce, but that baby will have a mutation. So how are you going to determine what that mutation is? This is when your coin flipping and die rolling comes into place. So the first thing you're going to do is you're going to pick up your coin and you're going to flip it. If you get a heads, that will mean that the mutation is going to be on the bird's front wing. If you get a tails, the mutation is going to be on the bird's back wing. Okay? So now that you've determined which wing is going to be mutated, you then have to figure out what the mutation is going to be. So if you roll a 1, 2, 3, 4, 5, or 6, you can see in the table what that mutation will be. So if you roll a 1, you're going to move the wing 1 centimeter towards the front. If you roll a 4, you're going to decrease the wing circumference by 2 centimeters. And if you roll a 6, you will decrease the wing width by a centimeter. So again, either position on the body, the circumference, so the size of it this way, or the width, so how wide is that paper slip. So those are the 3 things that can be mutated. So again, if I get a tail and then roll 4, I'm going to go to the back wing and I'm going to decrease that wing circumference by 2 centimeters. Please note some of these mutations may cause you to have to cut a new wing and tape it back on, like if you had to increase the wing circumference, and some of these mutations may actually involve a lethal mutation. That means the wing completely falls off and then your bird will have died and will no longer reproduce and your experiment will have to end. So after you've determined what these mutations are, again you're going to record that in your table under generation 2. So now with these one genetically identical bird and the one new mutated bird, you're going to fly them again. Again, you're going to keep sitting in the same spot, measuring the same way, throwing in the same way to make sure everything is identical, and you're going to record again your qualitative and quantitative observations about these flights. You're then going to repeat steps 2 through 4 and continue this cycle of reproduction, and do this so you have data for 10 generations in total. Then on your handout and online in class, we're going to discuss what observations you made about the mutations and what qualities or what traits were favored by natural selection in this example.